In this lesson, we will explore concepts for how to manipulate lists and nested lists in Dynamo. Let's begin by constructing a sequence of numbers to define the x and y coordinates of a point-by-coordinates node. I will use the search feature located in the node library to add the integer slider, number node, and point-by-coordinates node to the workspace. In the number node, I will enter 0, *#a, to create a sequence of values starting at 0 for a count of a at an increment of 1. I will then connect the integer slider to the a input port of the number node. Let's search for a watch node to see the results of changing the integer slider. I will connect the number node to the watch node. Once these have been connected, I will press run. Notice that the list starts with an index of 0, ends with an index of 49. The total number of items in our list equals 50. Moving our integer slider, you can see the changes occurring dynamically. Set the integer slider to a value of 10. To navigate the background, use Ctrl-B or toggle in the bottom right corner of the viewport. Let's connect the output of our number node to the x input port of our point-by-coordinates node. The resulting sequence of points is flat, or a single continuous list. Each point in the list corresponds to an item index. To see this better, let's go ahead and connect the output port of our point-by-coordinates node to our watch node. Navigating our background 3D preview, let's zoom in to gain a better view of our points. You can select a point from within the watch node and see the index displayed dynamically in the background 3D preview. Using the list getItemAtIndex node, I can retrieve a specific entity from a given list. Typing getItem into the search field returns getItemAtIndex. I will supply the list of points to the list input and use an integer slider to define the index. Notice that the index 50 is greater than the largest index in our list. I will modify the range of the slider by clicking on the bottom right corner of the integer slider and modifying the maximum value. Let's create a polygon to more clearly view the isolated points. To do this, we will first need to create a circle by center point and radius. Browsing to the node library, we will click on Geometry, Circle, Create, by center point radius. Use the output of getItemAtIndex to define the center point and the number slider to define the radius. Making changes to the number slider, you can see the circle updates dynamically. Going back into the geometry category in our library, browse to regular polygon. I will connect the output circle to the input circle on the regular polygon node. I will use a number node to define how many sides I would like to have in my polygon. In this case, I will use the number 4 to create a diamond. As I make changes to the slider identifying which item to pull from the list, you will see that the circle and polygon are updating in the background 3D preview. If you would like to view either the circle or the polygon, right-click on the corresponding node you wish to hide and turn off the preview. To modify the structure of our points, I will right-click on the point-by-coordinates node and change the lacing option to cross product. Remember that the current lacing option is indicated in the bottom right corner of the node. The cross product shows 3 X's as an icon. Now we will copy and paste the integer slider and number node to define a new sequence of values for y. In doing so, you can see our list of points is now a grid. By changing the number of points defining y, we can see that the background 3D preview will update dynamically. The number of elements in our list can be computed by using the list count node located at the core list action category. I will connect the output port of my point-by-coordinates node to the input port of my list count. Using a watch node, I will take a look at the result. Here I can see that 10 items exist within my list. This corresponds to the number that we defined here in our number sequence. Let's again compare this number to the output of our point-by-coordinates node. Clicking on the plus or minus in the watch node, we will collapse or open the list that it contains. If you would like to see how many items are contained per nested list, we will need to use the list map node. Typing map in the search field, we will see that under the core there is list evaluate list map. Let's connect this node to the output of our point by coordinates node. The function input port specifies which function to apply to the element in a given list. Let's connect the list count node and view the results using a watch node. Notice that Dynamo has thrown an error, and by hovering over the balloon, we can see a message pop up. The warning indicates that a function input should not receive a list count connected to another list, but rather you will need to add a new list count to the workspace. Notice the list map is returning the list count for each of our nested lists. Next, I would like to switch the rows and columns in our nested list of points. To do this, I will use the transpose node. By connecting the output port of the point by coordinates node to the input of the transpose node, I will see that I have a new list of points where the columns and rows have been swapped. To see the results of the transpose node more clearly, I will connect the output of my transpose node to the input of my getItemAtIndex node. We can now see in the background 3D preview, we have switched from columns to rows.